All right, so we're here building our first shooter prototype of the season. This prototype is designed to see whether or not we can build a turret without ever actually having to move the wheels around. So we have two drums, one on the right, one on the left, and these are going to send the fuel up into the air without any spin, and then we're going to have a macker mounted on top on our Lazy Susan that's going to be turreted. And the goal is that this macker will redirect the ball's path while adding a little bit of backspin, so we can get a little bit more accurate with it, get a little bit more range, and just generally have a turret without having to go through any of these difficulties associated with moving wires around in a circle and making sure we have long enough wires and not ever, you know, pulling our wires out or none of that mess. We just have a nice analog thing on top of our turret that can move without having to be attached to anything else. So basically right now we're just checking to make sure roughly about how much power we actually need to climb. So basically just a confirmation that we can do it with just one sim, which on the actual robot we should be doing it with more, but it's just a proof of concept. Our next step is going to be figuring out our attachment mechanism to actually grab onto the rope before we climb. If GDC allows it, we'll be doing Velcro probably. If not, we'll be figuring out something with hook and loop along the lines of what you saw with Green Orange RI3D.
Hey, I'm here to talk about our drivetrain. Currently, we only have one side of the, half a side of the prototype done. So basically, we're going to be doing 2+2 on our robot. There's going to be omnis in the back, and there's going to be a traction wheel in the front. You can see in this drivetrain wheel already that we're going to be cutting it really, really close on spacing. That's because we want to maximize as much area as we can in the belly pan area to give us as much ball area volume. We got both of the rails assembled, and now they're held together by the belly pan and a back 2x4. And pretty soon we're gonna have some pieces of wood attaching the intake and hopefully the shooter sometime this weekend.
We have our prototype for our gear intake. So this is, right now it's not attached yet, but we plan to attach it to our robot with pivoting hinges, and so that we will be able to lower this. It's with the system similar to like our intake for the balls, and then these four wheels will spin in when we attach a motor, and it'll pull in the gear and hold it here in the rack. And later on we're going to tension these that way so we can hang them on the peg for the gear.
Alright, so we made some upgrades to our drivetrain. We've included an electrical system now, very basic. We also have a little piece of chain tensioner so that way the chain doesn't sag on the floor anymore. We also have a really, really heavy collector that we're mitigating with some gas shocks on the side. And hopefully we'll continue progress on this as we continue.
Alright, welcome back to Check-In. Our next team up here, it's Spectrum, team 3847. They're from Houston, Texas. It was a great video, guys. Showed us a whole lot of stuff you guys were up to. Why don't you guys introduce yourselves before we get started?
I'm Will. I'm a senior on the team, and I help a lot with CAD, manufacture, and prototyping.
I'm Alan Gregory. I'm the head coach for Spectrum.
I'm Mary, and I'm a senior on the team, and I help with mechanical and stuff.
Very cool. All right, well, welcome to Check-In, guys. Just a message for all the viewers live at home. If you've got questions for Spectrum, you can ask them in the Twitch chat. Again, !Q, then your question. And if we like your questions, we'll ask these guys live on air. So let's get started here. First, let's talk about the general game strategy. I think last week you guys had pretty much nailed down what you guys were looking for your general game strategy, not necessarily robot specific. So why don't you refresh everybody about what your plan is for the season?
So we're looking at we think we need to be able to do all three of the tasks, so gears, fuel, and hanging. But we think that there's going to be sort of a transitional period in a match where we go from having to do these gear cycles and maintaining ball cycles, with the gear cycles being a little bit more important, to switching entirely to just doing the ball cycles and getting them into the high efficiency goal.
Okay, so how does that translate into what your robot's going to do? Are you prioritizing shooting over gear scoring, or are you not quite sure about that necessarily?
So we're making sure that we can do the gears. We want to make sure that we're planning to be able to hopefully do at least 5 to 6 gears a match. We're not trying to be one of the robots that is attempting the 10 or 12 gears a match thing where you're doing cycles in every 10 or 11 seconds. That just doesn't seem feasible. If you do cycle counts roughly the same speed as like 2013, 5 or 6 is possible. If you do that while being able to score balls, you should be able to get hopefully will be able to win the matches that end up 6v6 in gears for each alliance.
Okay, very cool. All right, so now that we've got your general plan going, why don't we talk a little bit about how exactly it is you guys do your prototyping? So it looked like, by the way, that was a great time-lapse video. We get to see literally everything going on there. We saw a lot of old robots. We even saw a robot in 3 days, Team Robot, which was, of all the robots in that room, that was the one that got touched the least, interestingly. So why don't you guys tell us about what your process for prototyping is?
So we do a little bit of everything. So a lot of it comes to our CNC router. So we're able to route plywood and make a lot of our parts. So we do a lot of design work first before just prototyping. So it's not a lot of just screwing things together. We actually CAD most of our prototypes. And then we go about actually using old robots or control systems that we have either on test benches to control them as much as we can. So we're getting finer control than just plugging in things to a battery and hoping it works. Will can talk a little bit more. He did a lot of the shooter prototyping this past week.
Yeah, so our first day of actually prototyping, we didn't even touch any 3D stuff. It was all, we've been watching Adam Hurd 971's ramp series, so he's talking a lot about designing your mechanisms in 2D sketches all the way through, just so that when you actually go to put everything into a 3D model, you're not worried about like, okay, are these things going to interfere? You know, what's this whole space? And you've already got all that stuff figured out. It's just making the 3D parts. So then we go from there to, putting all the parts in, getting stuff sent to the router, and then after that, it's assembly and testing. And you mentioned all the robots. So we actually try to use, we had NRG sponsored a sort of a robot football showcase earlier in the year, and we had designed a series of PID shooters for that robot. So I just opened that robot, pulled up that driver station, and changed all our PID set points to tune it for the new shooter. I didn't have to write any new code for it. I didn't have to set up any new control systems. I just hot wired off the old one and made it work.
Wow, so you guys are already using like PID control on your prototypes?
Yeah, we want to make sure that our goal for PID testing, these last few days was to make sure that the shooter setup we have can work once we start refining it a little bit. So making sure that, if we can control speed, does the diameter roller we've chosen work? Does it work at the speeds we think we can make it run at? Are we going to get the right kind of arc? Can we make everything work, really, is what we were trying to make sure we can do. So we wanted to get it as refined as possible.
Okay, cool. I kind of want to just talk about your router a little bit. So do you have one in shop in your facility, or do you have a sponsor that you send the CAD models off to, and then the next day we've got some parts ready to go?
No, so we have a ZenBot 24x48 router in the back corner of our shop. So it's kind of hard to see in the time lapse, but it's the thing that all the people on the computer are working on all the time. Yep. So that's them we do most of it out of just cheap plywood. Some of it's out of Baltic birch for some stuff, like the whole chassis is out of Baltic birch, so it's a little bit more rigid. But we can route parts all day on that thing and make whatever 2D flat parts that we want. Next to it is our 3D printer that will actually be printing. We print polycarb parts on that. So we printed 40 18-tooth HDD pulleys this past week for some of our intake prototypes.
This polycarb?
Yeah, it prints entirely out of polycarb.
That's a pretty legit printer.
Yeah.
Awesome. So, kind of going off of that, you guys mentioned your chassis there, and this is something I don't really see very often teams do. You guys are prototyping your driveline. I saw one of your students laying out all the gears and the sprockets, and then the next shot we have a chassis made out of wood. Why are you deciding to prototype that as opposed to just, assuming it's all going to work?
We want to. If we assume it's going to work, you never know what's going to pop up on the final sheet metal version of it.
But you know what they say, when you assume, you're almost.
That's a big part of it. But even little stuff. So we're checking to make sure we use a chain calculator to calculate how long the 35 chains need to be. But we never quite, depending on the length, it's never quite as the tension that we want. So if we make one out of wood, we can feel it, actually see how long it's going to be. The next version is just a little bit better. When we're actually playing and mounting stuff, it gives everybody a better feel of how big the robot's going to be, how big their mechanisms can be, what it's going to interact with. And we can just test to make sure it's actually going to drive the way we want it. We're able to mount everything. If the ground clearance seems reasonable, we're pushing it pretty low this year. I think the chassis is a 1/4 inch from the ground. Yeah. So all of those things we haven't ever necessarily done exactly like that before. So we want to get it as close to tested and mounted and do the intake mount to the chassis rails the way we think they are. So we can design it a lot easier if we have something to actually mount everything to.
So is this woodbot going to drive, you think?
It should. It should have actually already been driving. We have there shouldn't have been too much left to it. We actually killed one of our Robo Rios that we need to RMA, so that was interesting. We had to pull it off a different one off of last year's robots. We had some electrical issues, but hopefully in the next couple days that'll be driving. The shooter should be getting built and put onto it. So hopefully all of it will be integrated by the weekend.
And right before you guys called, I was finishing up some of the code to get it running. So hopefully we'll be able to get it driving tonight. We'll see about any other functions, but driving should be done before.
Nice. Well, hey, having a driving robot one weekend, can't complain about that. So, all right. So let's talk about the rest of the stuff you guys are prototyping. Tell us about your shooter. You guys explained it pretty well in the video. You're looking to do like a turret, but a turret that doesn't have any wires. How does that all do?
So that was our original plan, was to see if we could turret without having to move any of the wheels. Yep. But we did a little bit more strategic analysis, and we were thinking that the benefit of being able to shoot from anywhere on the field, one, it's going to be tough because unless you have like some crazy control systems people, you're going to be having to tune each shot individually, and you're not going to be able to just sit down and fire a shot. So because we don't quite have that capability, we figured, okay, it's going to be a much higher barrier to entry to get a turret working properly. And if we take a little bit of an easier shot, we might be able to get better ball throughput. So our new plan is to set up basically a drum that's about 15 inches wide, 15 inches long, and just put 3 balls in at a time into the high efficiency goal. So we figured we can get greater ball throughput without nearly as much hassle. And we think it'll be more viable because it'll make our cycle times a little bit shorter. It gives us a nice set reference point for taking our shots, and we don't have to deal with turrets breaking on our first ever turret robot.
Yeah. So what kind of range are you looking at? Are you looking from going right up against the boiler?
Right up against the boiler with our tower all the way at the back.
And then preferably a shot right up to another robot at the boiler, whether that be an opponent that's trying to defend us or our own partner that may be shooting there too.
I see. Kind of like 254 in 2014, how they'd have the shot against the goal and then one robot back.
Yep.
Yeah. Very cool. Hey, you guys even built a wood robot like they did. So a couple of years hold together better.
The shooter prototype that's still left to be prototyped is the idea is that the 3Y is currently we're planning to be able to turn off either the left or right channel. So if we're not aligned perfectly, we can still be shooting two channels with balls in, and then still cut off either left or right. So if we're all perfect, we can be making 3, but we may only be doing 2 wide.
Are they segregated, you think, the channels? Well, I mean, you guys are still going to have to prototype, but you're still working on that, but you're thinking they're segregated?
Yeah, so each elevator, there are 3 separate paths up, basically, one hopper that feeds into 3 different paths going up the elevator.
Okay, very neat. That's kind of cool, actually. I'm a fan of that. So we saw some gear stuff going on there. Why don't we talk a little bit more about the gear manipulation? We know that's secondary, but I still want to hit that.
Yeah, so we definitely know that gears are important, clearly, and we've been working on a few different ways to do it. We want to make sure that we can do them off the ground. And one of the big things we've been playing with is trying to figure out our gear sub team. They're not on the call right now, so that's why I'm talking. They're making sure that we can get the gear to actually go onto the back of the spring, because it is a little bit of a flexible spring. We've seen enough videos from other people and from the real field that if you put it right on the front, there's no guarantee that it stays there. So making sure that we can actually deposit it on the back wall and then be able to drive off.
Okay, so your focus is to actively bring in the gear from the floor and then jam it onto the peg as you need it.
Right.
Okay.
So for a slightly faster cycle and just make it a much more solid deposit than just hoping the spring kind of pulls it off.
Okay. So we've seen a lot of teams so far on check-in who aren't going with an active gear pickup mechanism. They're just basically accepting them from the human player. What was your analysis that led you toward going for a active mechanism?
Part of it was that we're going for the short configuration. So the place where the gear comes out is the same height where the ball comes out. So we were just having some trouble figuring out how exactly we were going to redirect the gear to go into some passive mechanism without it interfering with balls going into our hopper. And we're just getting really convoluted, and we weren't quite sure how we were going to do it. And then we also weren't quite sure about if we were going to have to back up from the wall in order to get it to fall in properly, or if we were going to be able to drive up or not. And we also realized, okay, it might just be easier. Well, actually, the other reason is because we weren't quite sure about orientation, if it was going to be on the back or the front, and whether or not we'd have to turn around to accept balls or not. So we figured, all right, if we can just have our human player drop it on the floor, we can drive up, pick it up, and then have them just drop the balls immediately onto us. that'll make for a little bit of a faster cycle than having to like accept a gear, then like put down some flap to block the gear, and then accept the balls.
And the other, a lot of that just came from doing cycle time analysis and figuring out that if the gear's already in the floor and you're picking up balls while going there and coming back, and you don't even have to align to the feeder at all, possibly for a lot of your cycles, you'll be faster than having to do that alignment.
Oh, I see. Okay, so you're betting on entropy basically, to a certain extent.
Yeah, lots of balls on the floor.
There's going to be a lot of balls on the floor.
All right, so we're almost out of time, guys. Do you have anything else you want to bring up on this week and check in here? Any other prototypes or any other cool stuff you guys did this week that we didn't cover so far?
No, we'll be getting, so we actually just sent our first run of sheet metal out. So we're mostly a sheet metal team. So we have the router in-house for a lot of our prototyping, but we do send sheet metal for our actual robot. So that just went out for the actual sheet metal chassis, the first version of it, not like the duplicates that we'll have for the practice robot or anything. So we'll actually prototype it basically twice when you're talking about only prototyping the chassis once. One of us whole second one too out of actual sheet metal. And that one will get completely built. That one will drive. We'll take all the electronics off of prototype 1, get that one moving here pretty soon. Hopefully back before the weekend. We'll see if our sheet metal shop's that fast or not.
So you guys will have built a wood robot, then you will have built a sheet metal prototype practice bot.
Correct.
Yeah.
You will have built your real bot, and then you'll have spares.
And then we'll build a practice. No, we'll also
And
there'll be a whole practice bot too, because the practice bot's identical to the real one. Where the prototype chassis will probably have some changes into it.
Okay. Well, next week we're going to talk more about this. I'm really interested to see how. Not that I doubt you guys, but I want to really touch on how you can build multiple robots in the season. Because that seems pretty dope. So, all right, we're going to say goodbye to you guys for this week, and we look forward to talking with you next week. Up next, geographically further west, just by a few hundred miles, is Team 148 from Greenville, Texas. So we're going to take a very quick break. Spectrum, thank you guys. We'll see you next week, and we'll be right back with 148.
Bye, everybody.